So let's look at this first example now. So we've got it says find the equation of a line which is perpendicular to y equals 2x plus 6 and passes through the point of 8, 1. So the first step I need to do, the first step is to find the perpendicular gradient, right? So if this is my line here of y equals 2x plus 6, I could maybe make a little sketch of that. So it's going to be quite steep. It's positive because my gradient here is 2, and it here has a y-axis intercept of 6. So it passes through the y-axis at 6. So if this is my line of y equals 2x plus 6, I want to find the perpendicular gradient. Okay, so if I know we have line 1 has a gradient of 2, I could write this as 2 over 1. So the gradient of line 2, which is the perpendicular gradient, is the negative reciprocal. So I flip this fraction, so it becomes 1 over 2, and I change it from being positive to negative. So the gradient of my perpendicular line is in fact minus a half. Okay, the second step that we need to look at is to find the equation of the perpendicular line. Okay. So if I just think about that visually, I know it's going to pass through the point 8, 1. So it's going to be down here somewhere. So the perpendicular line might look something like this. Yeah, if I just sketch it, so the perpendicular line would look something like this. Okay, of line 2, the perpendicular line. So what I need to use is the general form of an equation of a straight line. So y equals mx plus c. I know it passes through the point of 8, 1. So x is 8, y is 1. And I know it has a gradient of minus a half. And all I'm going to do is I'm going to substitute all of these values into my equation of a straight line to find the y-axis intercept. So now I'm going to find C, the y-axis intercept. So I get y is 1, m is minus a half, x is 8 plus c. Now I can actually solve that. So I get 1 equals minus a half times 8 gives me minus 4 plus c. So if I rearrange this to make c the subject, I get 1 plus 4, which gives me 5. So the value of c, the y-axis intercept, is in fact 5. So there's the 0.05. So therefore, we're not quite finished. So therefore, the equation of the perpendicular line, just abbreviate that, perpendicular line, is going to be y equals minus 1/2 x plus 5. Okay, right. The next question I want you to try yourself. You can press pause, try yourself, and put in, try yourself to find the equation of the line which is perpendicular to y equals 2/3 of x plus 4. Okay, so hopefully you've had a good crack at that. So the first thing we need to do is find the perpendicular gradient. Okay, so if I know the gradient of this line, the gradient of line 1 is 2/3, that means the perpendicular gradient, L2, would be the negative reciprocal of 2/3. So I flip it, that's 3 over 2, and I change the sign. So that's what I'm after. Second step is I need to find the equation of the perpendicular line. Okay, so I'm going to use y equals mx plus c. I know I've got my gradient of minus 3 over 2, and I know we've got the point of 2 and 1. So x is 2, y is 1. So let's substitute that into my general equation to find c. So y is 1, m is minus 3 over 2, x is going to be 2 plus c. If I multiply out the brackets, I get 1 equals minus 3 over 2 times 2. Well, the 2's cancel off, I just get minus 3 plus c. If I rearrange this, we get 4 equals 2c. So the y-axis intercept, this is the y-axis intercept, is in fact 4. So coming back up here, I can say the equation of the perpendicular line is going to be y equals to minus 3 over 2x plus c, which we found here, of 4.